All right, so today is chapter 1, lesson 4. You guys are looking at me so funny. We're not going to do a bell ringer today because I wanted to go over what we did in class yesterday. Okay, so today is proportional and non-proportional relationships. Has anybody heard of proportions before? Have you heard of a proportion before? Yes, you've heard of it before? Okay, so that's a good step. So my first question to you, so those people who have heard of it before, my question is, no, not going to happen. My first question is, what is a proportion? What is a proportion? What do you think?
Like a gap in something. Like how much is in this room.
Okay. Anybody else have a guess what a proportion is? Cora? Okay, getting closer. Yep. Kind of. It's not a fraction. A lot of people think it's a fraction, though. Okay, anybody else got a guess? Evan? Okay, here is the definition. Make sure you get this written down, and I will explain it to you. A proportion is when two ratios are equivalent, or are the same, basically. So when a proportion is when two ratios are equivalent or the same. And then here's an example you can write in your notebook, because we're going to use this. We're going to come back to this a few times, so make sure you get this written in your notebook. So by looking at these examples, a lot of you would say, oh, it's a fraction. Let me explain the difference between a fraction and a ratio to you. Okay? Before, when we've talked about fractions, a lot of you said a fraction is part of a whole, right? Okay? A ratio is comparing two different things. So let's go back to like the day we talked about rates. Remember we talked about like games, points per game, and we talked about a few other things. So a ratio is comparing two different things, and this would be a ratio because you're comparing what? Miles and hours. It's not a true fraction. A fraction would be like, I ate 1/2 of that pie. Okay? That's not a ratio. A ratio is comparing two different numbers. Now, if I look up here, these two ratios, this one and this one, are equivalent. They're in proportion. Okay? If I look at these two, how could I tell, or how would you know that these two are in proportion? David? They both have what? Okay, they might not always be in proportion if they're miles, though. What's another way? Yeah, Bryn. Maybe. Brandon? Okay, so let's look at that. Is one double the other one? Okay, that's one way to tell, and I'm going to come back and show you about 3 different ways you can tell if something is in proportion. Just because they have the same labels doesn't mean they're going to be equivalent. Okay, the next vocabulary word I have for you is non-proportional. Okay, after we talk about stuff that's not in proportion, you're going to start to see, oh, I'm starting to get it now. Okay, and then I'm going to tell you 3 ways you can tell if something is in proportion or not. So non-proportional is when the ratios are not equal or consistent. And you might be looking at this right here, and you're saying, what does that even mean? This is a sign to say not equal. Okay, so when you see an equal sign that has a line through it, that means not equal. Okay, so that's something new for you. Now, if I look at these, they're feet and seconds, but these are not in proportion. Why would these not be in proportion, Brandon? Okay, so let's look at this. I know this doubled is 10, right? What should this doubled be? Is it in proportion? No, it's not. Okay, now let's talk about 3 ways. Let's talk about 3 ways you can tell if something is in proportion. So 3 ways, you're going to want to know these. 3 ways to tell if something is in proportion. Alright, so the first way to tell if something is in proportion. Got a guess? Got a guess? What kind we've been talking about? Yeah. Okay, so I'm going to say if you multiply or if you reduce. And I'll go back and I'll show you what I mean by this. So the first way is if you can multiply by the same thing or if you can reduce by the same thing. Yep, question? Okay, give me 1 second because I'm going to explain this. I'm going to go back to this one. And let's talk about this one. So reducing, if I can reduce, what can this reduce to? 10 over, you see how if they reduce to the same thing, they're in proportion. Okay. Another way, what we just talked about, if you can double or triple both of them and they equal the same thing, like here I know what's happening. I'm multiplying by 2, right? Here I'm multiplying by 2. Does it turn out to be the same thing? Yes. Then it's in proportion. Is it kind of making sense to you now? Okay, like before, we talked about how this one wasn't in proportion because I multiplied by 2 here, and if I have to multiply by 2 down here, that should be 2, right? So this one's not in proportion. Another way I can tell if something's in proportion, and this is probably one of my favorites, is by dividing. And I'll give you an example of this too. We'll go back to that example. So if I go, oops, let's go back here. Remember how we said that these are a fraction, they're a division bar? What if I take 10 divided by 1? What do I get? What if I take 20 divided by 2? What do I get? So if they both equal 10, they're in proportion. Okay, that's another way. Yep.
So it's always the one to the left.
1 to the left. What do you mean by
Like,
that?
is it always going to be the...
Not necessarily. Not necessarily. This might be on the other side. That might be on the other side. Not necessarily. So if you can reduce them all to the same thing, then they're in proportion. Okay. Let's talk about another way. You're going to like this way too. The third way, and some of you maybe remember this from last year. Yeah?
Is it the numerator?
No, I'm going to combat and multiply. The other way is using cross products. You probably remember this from last year or heard of it. And I'll explain how it works. I'll just write it over here. I think it was 10 over 1 is equal to 20 over 2. Okay? Now watch this. Another way I know if something's in proportion is if I multiply across. What's 10 times 2? What's 20 times 1? They're in proportion. That's another way. So there's 3 ways there that you should be able to tell if something's in proportion or not. Don't come to me tomorrow and say, well, I don't know if it's in proportion. I'm going to say, go back to your notebook and look it up. Because I already told you 3 ways to be able to tell. Any questions on that? All right. Now let's talk about making a table that's in proportion. A lot of times when I do tables and I make stuff, I use pizza. Because evidently I'm hungry when I make these. So we're going to, if I were you in your notebook, I would copy this down and we're going to do it together to show you what you need to do. So complete the table to determine the amount of pizza ordered. Doesn't have to be perfect, just needs to be cost pizza. That's how it needs to look. Doesn't have to be perfect. Now to fill in this table, the first thing I'm going to look at is what's already filled in. And you guys have dealt with this before. Because if I'm breaking something down to 1, what is that called again? Do you remember? A unit rate, right? So here's my unit rate. So this tells me what? For every 1 pizza, how much is it going to cost? $8. We're going to use this unit rate to figure out the rest of my table. So if I buy 2 pizzas, how much is it going to cost? Okay, 3 pizzas, 4 pizzas, 5, right? Now listen, I'm going to ask you, is this table in proportion? It is? 100%? Okay. What is a way you could tell me why it's in proportion? Kenzie? Okay, what's another way I can tell if this is in proportion, Tessa?
Just divide 8 by 1, 6 by 2.
If I do that, what am I going to get? I'm going to get 8s, right? What's another way I could tell? Trevor? I'm adding 8 every time, okay. Kenzie? I could cross product. Yeah. 8 times 2 is what? 16 times 1 is 16. Can you tell how it's in proportion now? Also, another thing, stop talking. If I could reduce this, if I reduce this, what's it going to reduce to? 8 over 1. If I reduce this, what's it going to come? Okay? We just made a table that's in proportion. Let's do it again. Let's do it again. Let's do it again. You can do it by yourself if you want. And then I want you to give an example of why it's in proportion. Tell me why it's in proportion. Because they're going to ask you that in your homework today. They're going to say, well, why is this in proportion? So you have to be able to justify why it is. And remember, I told you 3 ways to be able to justify it. Sure, it's up to you. You're always going to go back to what? What's this called again? Your what? Unit rate. Remember, we did that already. We talked about unit rate. About done? Okay, finished? Okay, finished. So 2 minutes, if I type if Emily, I guess, types 2 minutes, how many words is she going to type? Somebody raise your hand and tell me. How many words is she going to type, Aiden? 100. Keaton Bonderson, if she types 3 minutes, how many words is it? Very good. Let's see. Daniel, if she types 4 minutes. And last but not least, Bryn, 250. Now, justify this to me and tell me why it's in proportion. Somebody I have not heard from today, tell me why. Drake. Okay. There's better ways to tell me if it's in proportion. That's not going to work every single time. Okay? Tell me a better way, David. I'm going to get 50, aren't I? What's another way, Eric Scheitler? I can do cross products. Yeah, that's the easy one to see, right? Trevor? So I took 50 times this times this times this. Let me show you some times when if you just add, it's not going to work. Can I do that? Watch this. Let's say I have 50 words for 1 minute. And let's say all of a sudden I get 100 minutes, and that's 2. And then I go to 4 minutes, and that's 150. And then I go to 200, and that's 6. Can you tell why this is not in proportion?
Yes.
Why not?
Because you can't get to 50.
But I added 50 every time.
But
But the
the bottom.
bottom. What about the bottom? The bottom has to also stay consistent. Okay? Yep. Correct. 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 I'm showing you, because Bryn, some people are like, well, I know this is in proportion because I'm adding 50 every time. Well, this is an example of adding 50 every time and it not being in proportion. Okay? So you can't just say, well, it's in proportion because it's adding 50 every time. That's not a good reason why it's in proportion. The good reason is oh, I divided and it comes out to this number. Or I can reduce and it comes out to be my unit rate. Yep. Sure, that would work. That would work. Yep. Very good. Tell me if this table is in proportion or not. Do not yell out the answer. Tell me if it's in proportion. Hunter? It is? What do you think? Cora? Why not? Yeah. That's one reason. What's another reason I know why, Trevor? Yeah. And, like, look at this. What's my unit right here? Okay, so what should 2 be then? What should 3 be then? What should 4 be then? Okay, you seeing it? Now watch this. Let's say this was my table. I'm going to redo this here. Let's say this is 20, let's say this is 30, and let's say this is 35. Is this in proportion? No, the whole thing has to be in proportion. Let's say I check these. Oh, this one works. Do I check these? That one works, but what about this one? It's not. They all have to be in proportion to be in proportion. You can't just say, well, that one's not, but the rest of them are, so okay, it is. Can't do that. They all have to be. Okay? Figure this one out for me. Is this in proportion or not? Don't yell the answer out. Think about it yourself. Is this in proportion or not? Daniel?
Yes.
Why yes? Hold on. How many were going to say yes? How many were going to say no? Okay. Tell me why, Daniel. Prove these people wrong and tell them why you're right. Okay, that's not a good reason, but you're on the right track. Keaton Bonderson? And 3 should be 1.5, and 4 should be 2. Do you see it now? Yes?
Yeah, because 1 is a whole, so if you first multiply 0.5 to that whole.
Good job. Nice work. Brandon? Yeah, divide it by the top or bottom, or even if I reduce, I could even divide the bottom and the top if I want it. You just got to be consistent. Yeah, very good. Nice work. This is what your homework's going to have today. Now listen closely. They're going to give you a table, and you have to fill it in. But there's a lot of reading that's along with this. For example, it says complete the table. Martin reads 60 words per minute. Do you know the unit rate now? Okay, so fill in your unit rate. I know it's what, 60 words in 1 minute. Then it's your job to figure out the rest of the table. Okay, so if I read 2 minutes, 120, 3, 4, holy cow. And then, ladies and gentlemen, it's going to ask you, is this table in proportion? And you have to justify using one of the 3 reasons why it's in proportion. Does that make sense? And I'm going to tell you, some of the tables that they're going to do today are not going to be in proportion. So don't think that every single one is going to be in proportion. Okay? Do you have questions for me? Brandon? Yep. Sometimes they will not be. Sometimes they'll tell you to do something different, and sometimes they won't be. So, no, I don't think so. Maybe, I'm not sure. You have to check the problem. Okay? Any other questions for me?